I wanted to help you go over the more patterns investigation homework. In this homework, we're looking at sequences. Now, it asks us to determine if the sequence is using addition or multiplication. Now, that is the same thing, and I'm just going to give you the name of it. The addition is the same thing as arithmetic sequence, and the multiplication is the same thing as geometric. Now, you don't need to know that for the homework, but that will help you go through and maybe find some YouTube videos or alternative helps that might be helpful to you. So A, we need to determine whether it is using addition or multiplication to grow or go down. So let's look at sequence 1. Okay, we're looking at A. We see it goes from 8 to 13. Let's try addition first. If I do that, I need to find the common difference. Just take the second one minus the first one. So 13 minus 8 would be 5. So I see it goes up by 5. What's 13 plus 5? It's 18. What's 18 plus 5? 23, 28. Every single time it goes up by 5, plus 5 each time. So we see that it is adding to the number each time. So I'm going to put addition. Okay. Now B. Write a rule that gives a method for determining all this stuff. Now it makes it really hard to understand what it wants, and the wording is confusing. But what it says is just tell me what's happening, okay? And so I would do something kind of like, add 5 to each term. And that's what it's looking for. It says, tell me a rule. Like, if you're explaining this to me on the phone, you're going to say, hey, it's adding 5 each time you get a number. And that's all B is. It just says, tell me what's happening. Okay? C. Give me the next term in the sequence. Well, if it's adding 5 each time, the next one would be 28 plus 5, which would be 33. And D, give me the 10th term in the sequence. Just keep it going. So it would be 30, 33, 38, 43, 48, and let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 53 would be number 10. And that's what it's looking for in the A, B, C, D. So let me do another example for you here. Sequence 2. A, is it adding or subtracting? If we add, it would be plus 4, but 6 plus 4 is not 18, so it's not adding. Okay, so that doesn't help us with that. Does it multiply? Times 3, times 3, times 3. It looks like it's multiplying, so I'm going to say it's multiplication. And every single time it's times 3. So B, it wants us to write a rule. Well, for something like that, I would just say multiply each term by 3. Okay, and then C. C is asking us to give the next term. Well, if it's times 3, then we just need to do 162 times 3. And if we do that on a calculator, we'll see 162 times 3 is 486. So times 3. Okay, and then it wants the 10th term in the sequence. And all you have to do is just keep multiplying everything times 3. So times 3 times 3 times 3, and you'll see it just keeps getting bigger and bigger and bigger. And when you get to the 10th number, wherever that is, then that's what goes in here. Okay, so that's how you do the first section. Now the next section is it's got these pattern blocks, Lego type things, and it wants to know what's happening. Well, if we look at it, we say, okay, how is it increasing? Plus 3, plus 5, so that doesn't work at all. Okay, how about times 4, times 4? No, that doesn't work. So what can we do? We don't have anything. Is it multiplication or is it division? Or, excuse me, multiplication or addition? It's neither. And it can be neither. Okay, now it wants to know a pattern. Well, there's still a pattern. That's, 2 times 2. That's 3 times 3, 4 times 4. So this would be 5 times 5, which would be 25. So we see the pattern are just perfect squares. C, it wants to know the next term. Well, we figured that out right there. It's 25. And then D, keep that going. So that's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and you keep going till 10. What would 10 squared be? It'd be 100. So the 10th term would be 100. And you can just keep them going all out and just count if you want. Okay. The next one, it's still got a pattern. Okay, you got to figure out what the pattern is. Am I adding or multiplying? And then, figure out what the pattern is. So if it's multiplying, what are you multiplying by? Multiply each term by something. What would the next term be? Okay. Same thing here. 1, 8, 27. What would be next? Did we times it by 8? No. Are we adding 7? No. So it's, in this case, A would be neither. Okay. Now what's happening? Well, it's a cube. So 1 cube, 2 cube, 3 cube. So this would be 4 cubed. And so, B, you would probably say something like perfect cubes. C, what would be the next? Well, in your calculator, find out what 4 cube is. And whatever number you get there is what goes in C. And then D would just be whatever 10 cubed is. Okay. Number 7, same thing. We're trying to find the pattern. So here we see it's 2 cubed, 4 cubed, and then we see 1, 2, 3, 4, 5, 6 cubed, and so on. Okay, so we can watch that. Let's see. I think that's about everything here. Part B. Joe receives $2 plus $1 each box he packs. Michael receives $2 times the number of boxes, times the number of boxes packed. Write an expression to represent this. Well, For Joe, you know, he's getting $2 plus $1 for each box. Well, we don't know how many boxes, so, you know, $2 plus 1 per box. And we see Michael is getting $2 for every box, so that would be like 2 times x. Okay, and then it wants you to write an equation. So that's like saying y equals. That first one's y equals, you know, just keep it the way it is, 2 plus 1x, or x. And keep this one the same. The only difference is here, you have to add an equation in, so the equals. Okay, represent both expressions and equations numerically for the first 100 boxes packed. So that means Joe, okay, if he packs 1 box, 2, 3, 4, and so on. If he packs 1 box, he will get $3. How do I know that? Well, remember his was y equals 2 plus 1x. So what's 1 or 2 plus 1x? That's 3. What's 2 plus 2 times 1? And that would be 4. And then 5, and then 6, and then so on. Okay, so we're just taking this number and plugging it in right there for x. Okay, and same for Michael. We're just plugging it in for x, and Michael's equation was y equals 2x. That means 1 box will get Michael $2. 2 boxes would be $4. 3 boxes would be $6. I'm just timesing everything times 2, and so on until you get to 10. Okay, how do the patterns differ? Well, that's something you're going to have to just tell me in your own words how they're different. So hopefully this helps you get through that assignment. If you need more help, please feel free to let me know.